Hey everyone, how's it going? Next, I'm going to solve merge k sorted sets. This is problem number 23 on Leetcode. This is one of the top most asked questions in Amazon, Facebook, Google, and so on. Let's just go through the question stem. It says merge k sorted linked list and return it as one sorted list. Analyze and describe its complexity. So what this means is, let's say we have a list of linked lists. So we have like one with node one, which is connected to 4 to 5. Then we have another set of elements in a linked list. So 1, 3, 4, 2, 6. And what we want to do is um, we want to extract each and every element from each and every one of those linked lists, and we want to put them in an orderly fashion, in a sorted manner, and return one output. So now there are several ways in which we can do that. The first way is we can iterate over each and every item in the linked list, in this list, and then over the linked list consequently. So we start with one, we create a temporary list, and we keep on adding elements to it. So we add one, then 4, 5, and we go over here. So 1, 3, 4, 2, 6, and then we sort it. So the runtime of that entire solution would be O of n log n, because the sorting algorithm runs in O of n log n, and looping over this entire thing would be O of n square. So my bad, yeah, it would be O of n square, because we are actually looping over the entire list twice, once over each and every element in the list, and then over each and every element in the linked list. So that would be O of n square. So runtime of that solution would be O of n square plus O of n log n. Now, I'm not going to discuss that particular solution in detail in this video, because we actually have a better one, which would run in O of log n log n. Um, and so how would it work? So there is a concept called priority queue. Now you might have already heard about queues in general. So this looks like a queue where if we are trying to add elements to a queue, what it would do is, let's say we append 5, then 5 gets a position over here, then we append 2, then we append 1 and 4, and so on. Now priority queue works uh, in a similar way, but there is a small additional concept that we'll have to understand, that each and every element will be popped out or will be removed in the terms of the priority. So if we are trying to add an element to priority queue, this is an empty priority queue. So let's say we append 5. So right now there are no other elements, so it will be at the 0th index. Now if we try to add 2, what we see is the 2 has a higher priority as compared to 5. In Python, at least, all the priority queues are based on min heap, and what this means is that the smaller the element, the higher the priority. So in that case, this the order of the elements will change. So 2 will come over here and 5 will be here. Then we try to add 1. So in a normal queue, it will be added at this position in the queue. But then 1 has a higher priority as compared to rest of the elements. So 1 would come over here, 2 would be over here, and 5 would be over. And when we try to add 4, it will try to find the position for 4. So the 4 should come over here, and 5 would be over here. Since and if we have a structure that is similar to this, um, or which actually does this, then our job will be much easier, because now we can extract each and every element, and we can just keep them adding to which we can just keep on adding them to a priority queue, and that will solve our problem. So how would it actually work? So let's say we have this linked list. So this is what, like 1, 4, 5, 1, 3, 4, and 2, 6. We have the same set of elements over here. So 1, 4, 5, 1, 3, 4, and 2, 6. So I have added them to a priority queue. And since, as we just discussed, uh, the priority queues maintain the order of the elements in terms of the priority. So the top elements will always be sorted. Now, when we pop, or when we try to get the element from the priority queue, will initially we'll get 1, right? Because that's the element with the highest priority. So this will be removed, and we can place it over here. So this will be removed from over here and we can place one over here. Now what we see is in this linked list, the 4 becomes the topmost element, and when we try to add the same node to the priority queue, we'll see that 4 has actually a less priority as compared to the other ones. So this entire set of elements should be at the back. So the next time we try to get an element from this priority queue, it should be this one. So we get one from over here and it will be set over here. We can, and this is the new list that we are trying to create. So we can add it over here. And then this list will again have a less priority as compared to this one. So it should move. But where will it move? Because this element has a higher priority as compared to this one. So this should make space for it. And it will fit over here. The next time we get, it will give us 2, this element. So remove this, and this will have even less priority. So it will come over here, and so on. And ultimately, we will be able to form the output like 1, 3, 4, 4, and like the rest of the element like 5 and 6. Um, I hope that makes sense. The use of priority queues. I'll also let us walk through the code, and I hope if you have any other questions, then I'll be able to answer your questions when I walk through the code. So let's go over here. And for this particular video, I've already written the solution. Do let me know if you like this approach better than the other ones in which I actually type out the entire solution. So in Python, we import, there is a package called Q1 from which we import the priority queue. So let's instantiate the priority queue object. Now what I have done is I've created a head and a dummy node, and this is just to maintain the list that we want to return at the end. So what do? Initially, we loop over the entire list. So we loop over each and every element, and we put elements in the priority queue. How we do that? So what is the priority? The priority is the value of the first node in the linked list, and then L denotes L denotes the node of the linked list. So the first element that we put over here, its value would be L dot well. So we are already given the structure of the linked list or the list node. So value is given over here. So initially it will insert like for priority 1, it will be the node number 1 of this linked list. Then for priority 1, it will be node 1 of this linked list, and so on. Now what we do next is we have this priority queue and we want to extract elements from this priority queue. So we want to make sure that we keep on iterating over this priority queue till there are no elements in it. So we get the first element, and this is very similar to what we were doing over here. So we were getting elements one by one from we're getting elements one by one from that list. So we get the value. So value is this, that is the priority of the element, and the node. We get that from the priority queue. We create a temporary node because that is the one that we will be inserting into our output list. What we do is this is the temporary output list node. So we assign it to the next element, and this is like we had like if we have 1, then we want to assign something over here. So initially our current or our pointer would be at this index, and then we will want to move it to the next one. So we first assign 2 over here, and then we move our pointer to the next. So tmp.next. And then since we have already extracted the element from the normal list, we will also try to and move the pointer on that linked list as well. So that's what we are doing over here. If I go over here, then when we were moving, so let's say when we remove 3 and we move it over here, then we want to make sure that the that the top index moves ahead and it goes over here. So that's what we're doing. And so if the current exists, then we want to we want to offer it back to the priority queue. And we will do this till we have any elements in priority queue. And at the end, this will get out of the loop, and then we return head.next. Since head is still holding the reference to the initial dummy node that we had created, the head.next will hold the reference to the first element that was added to this dummy node. So it would be 1 in this case. Let's try to submit this. Yeah, okay, so that works. And fingers crossed, and it works. Perfect. So do let me know if you have any questions, if you have any other requests, or if you want me to solve any of the problems, just comment me in the video below. Do like, subscribe, share, and have a good day. Bye bye.